So here is the example number 3, and that says x square plus y double dash plus 3xy dash plus 3 into y equals to 0. So we make, you can construct with the help of the substitution y equals to x to the power m, but here I am doing the auxiliary equation directly by selecting a here is 1, b here is 3, and c here is 3. So I am constructing the auxiliary equation, and that is a into m square, that is 1 into m square, plus b minus a, 3 minus 1 into m plus 3 equals to 0. So m square plus 2m plus 3 equals to 0. Now this cannot be factorized. I cannot see any factors, and this can be done by completing square, but here I am replacing a quadratic formula. So by quadratic formula, that becomes m equals to minus 2 plus minus 4 minus 4 into 1 into 3 divided by 2 into 1. So that makes minus 2 plus minus 4 minus 12 by 2. So that arises to the complex conjugate roots. You can definitely see this. Okay, so that makes minus 8. That means 8 iota. Okay, so 8 has the instead of minus under root 1, I will write iota, and 8 square root of 8 is 2 under root 2 iota divided by 2. So if I divide 2 term by term, it will become minus 1 plus minus under root 2 iota. So here m1 is alpha is minus 1 and beta is under root 2. So minus 1 plus under root 2 iota, and m2 is minus 1 minus under root 2 iota. So the general equation becomes C1 complex conjugate roots. That means case number 3. C1 x to the power alpha x to the power minus 1 cos beta is under root 2 natural log of x plus c2 x to the power alpha minus 1 sine of under root 2 beta natural log of x. So here is the solution that falls into the category of case 3, complex conjugate roots. Now the next example is x cube y third derivative plus 5x square double dash plus 7x y dash plus 8y equals to 0. So I think that now I will move further and I will do the substitution, because here are a, b, c, d. So a lot of effort is required here. So let y equals to x to the power m, and y dash is m x to the power m minus 1, and y double dash is m into m minus 1 x to the power m minus y third derivative is m minus 1 m minus 2 x to the power m minus t. Now replace all these y derivatives and simple y in this equation. That makes it x cube y is m into m minus 1 into m minus 2 x to the power m minus 3 plus 5x square m into m minus 1 x to the power m minus 2 plus 7x m x to the power m minus 1 plus 8 x to the power m equals to 0. Now I can see that 3 and minus 3 gets cancelled, so that makes it x to the power m, and I know that x to the power m, and here 2 and minus 2 gets cancelled, x to the power m is common. 1 and minus 1 gets cancelled and x to the power m is common, so eventually x to the power m comes common. Okay, so rest of the terms are minus m into m minus 2 plus m square minus 5m square minus 5m plus 7m plus 8 equals to 0. So that makes it, as we know that x to the power m cannot be equal to 0, so we ignore this term from now on. So that becomes m cube minus 2m square minus m square plus 2m plus 5m square minus 5m plus 7m makes it plus 2m plus 8 equals to 0. Alright, so here minus 3m plus 5m, 5m square minus 3m square makes it plus 2m square, and 2m and 2m makes it plus 4m plus 8 equals to 0. Obviously you have to do the synthetic division. For that you have to find the root. So if I know that 1 is not the root because every term is a positive term and that doesn't makes it 0. So what should I do? I will replace it as minus 1. If I replace m is minus 1, that makes it minus 1 plus 2 minus 4 plus 8. It doesn't make it 0. Is m, if m is 2 plus 2 is not, if m is minus 2, then let m equals to minus 2. So minus 2 cube means minus 8. Minus 2 square is 4. 4 into 2, 8. Yes, it is a root. I can see that 4 into minus 2 is minus 8 plus 8. So yes, m equals to 2 is the root of, from synthetic division we can solve it and we can reduce it into the square form, from cube to square. From division we can also solve it. Minus 2 is the root, so m plus 2 is the root here. Okay, so by synthetic division you can also use the simple division method. We have studied in the lecture number 8 higher order homogeneous differential equation. In example 4 or 5 we have studied there. So m cube has the coefficient 1, 2 has the m square has the coefficient 2, m has the coefficient 4, and simple constant is 8, and our root is minus 2. So synthetic division is 1. So minus 2 into 1, that makes it minus 2. Minus 2, 2 minus 2 makes it 0. So again minus 2 into 0 is 0. So that makes it 4, and minus 2 into 4, minus 2 into 4 is minus 8. So that makes it a 0 remainder. Yes, it is completely divisible. So now your equation is reduced from cubic to quadratic. X square, that means m square, no m, plus 4. So now the other root is this, and the first root is m is minus 2, so that means m plus 2. So this is the root. Okay, I can see that if I split it, that makes it, it is a real root. m1 equals to minus 2, and for this it is m square equals to minus 4. That makes it plus minus minus 4 and plus minus 2 iota. Yes, complex roots. There is no alpha here but a beta here, that is 2. So okay, m2 is 2 iota and m3 is minus 2 iota. That makes your solution will be C1, because it is Cauchy Euler equation. So C1 x to the power minus 2 plus there is no alpha, so x to the power alpha is not considered here. C2 cos beta is 2 and natural log of x plus C3 sine into beta natural log of x. So this will be the solution.